Students will be selling flowers for homecoming. Comparing prices to determine the more economical option will now be done.
Good morning. Amy and I are with the senior class committee. We're looking for prices of flowers from different companies for our homecoming corsages.
My company, the Flower Power Company, can sell you flowers for a fixed down payment of $60 and an additional charge of 50 cents per stem.
My company, the Roses of Red Company, will sell our flowers for a fixed down payment of $20 and an additional 75 cents a stem.
I wonder which company has the best deal if we purchase these flowers from these vendors.
Hello, welcome to this portion of the Algebra 1 video project. We'll be dealing with equations, systems of equations, and inequalities. Systems of equations and inequalities are used in our everyday lives, whether you think so or not. Let's think about it. Everyone loves to shop, male and female. To be able to determine the better prices, to be able to do the most economical shopping, you can use systems of equations. Now, let's get into saving with systems. Our students will be shopping with one of two companies to purchase their homecoming flowers. They'll shop with either the Flower Power Company or the Roses of Red Company, since flowers for homecoming is a going thing these days. Flowers, flowers, flowers. Flower Power presents the following proposition. The homecoming committee will have to pay a $60 down payment and pay 50 cents per stem of rose that they supply. The Roses of Red Company's proposition is to have the committee pay a $20 down payment, but pay 75 cents per stem that they purchased. If they choose the Flower Power Company, for the purchase of one stem, the committee will have to pay $60.50. 2 stems, $61. 3 stems, $61.50, and the price will continue to increase by 50 cents for each additional stem they purchase, as shown in the slide. If they choose the Roses of Red Company, the first stem will cost $20.75. The second stem will cost $21.50. The third stem will cost $22.25, etc. The function for the Flower Power Company that's generated according to the cost of the contract they are offering is y is equal to 0.5x plus 60, meaning that they're paying 50 cents per stem of rose that they supply. X representing the number of stems to be purchased, plus the $60 down payment. The Roses of Red function is y equals 0.75x plus 20, with 0.75x representing the price per stem, again, x representing the stems purchased, and 20 representing the down payment required. If we take these two together, these two equations form what's called a system of linear equations. A system of linear equations is two or more linear equations together used to find a common solution. Systems of equations generate several types of solutions. One type of solution generated by systems of equations is the no solution situation. When systems of equations generate parallel lines, the graphs of the equations being parallel, there are no points of intersections. Therefore, there are no solutions to this type of system. Then you have the situation where you have a common solution. The solution of a system is simply any point common to the lines that are produced in the system. There's another type of solution that systems generate, and that's called infinitely many solutions. When the systems are comprised of equations that generate only one and the same line, infinitely many solutions are generated. The graphs of the equations are the same line. and all points on the line are solutions to the system. The functions that we're dealing with, y is equal to 0.5x plus 60 and y is equal to 0.75x plus 20, in our systems will produce a solution where there's only one common point. The solution of our system will be any point common to both lines. Now we'll visit our graphing calculator and take a look at how we can determine very quickly which company will provide the most economical offer. We'll enter our information into the graphing calculators and eventually generate inequalities so that we can see which company will provide the best contract. Take out your calculators and let's work on it. In the y equals of your graphing calculator, we'll enter the functions that represent Roses Are Red and the Flower Power companies. Flower Power is represented by 0.50x for the 50 cents per stem plus the $60 down payment that will have to be paid. For Roses Are Red, we're entering the 75 cent per stem, which is represented by 0.75x plus their $20 down payment. To be able to see the result of having entered these two equations in the form of a system, if you'll simply use your Zoom 6, you'll see the graphing calculator generate equations. But we can't see anything on the screen because the window needs to be readjusted. If you'll go into your window, let's go back first and revisit our equations. We see that one equation crosses the y-axis at 60. The constant in an equation is always the y-intercept. We remember that. Our other equation crosses the y-axis at 20. When we did a Zoom 6, we created what's called a standard window. The standard window is a window, we remember, that's 10 by 10. Surely we wouldn't expect to see an equation that crosses the y-axis at 60 nor 20 in a standard window. Therefore, we'll go into our graphing calculator and we'll readjust our window. We suspect that we won't have anyone purchasing 0 flowers, so we'll change anything less than 0 flowers. So we'll change the x min to 0. We'll adjust the x max to approximately 300 because that's a possibility for a purchase for the homecoming committee. Well, since we're enlarging our x's so very much, we must change our x scale so that the calculator can adjust and accommodate all of these numbers. We'll change our scale to 25 for our x-axis. We'll go into our y min and our y max and make the very same adjustments. Now from here, simply hit graph. And you should be, that's Flower Power coming in first, and Roses Are Red line came in second. The calculator has generated the two lines that represent our functions entered for Flower Power and Roses Are Red. The Flower Power lines extend from here to here. The Roses Are Red lines extend from here to here. If you'll notice, our Flower Power line came in first. Our Roses Are Red line came in second. I've got Roses Are Red marked in red and Flower Power marked in yellow. Now let's talk about these lines. The system we entered into the graphing calculator has generated two lines that has what's called a solution of systems, where there's only one common point to the systems. If you'll notice, the one common point appears to be, in our picture, in the center of the system. The places where the graphs cross the y-axis to the left are indicators of what lines represent what function. Since the lines marked with red arrows represent roses of red, we would suspect that those lines cross the y-axis at 20. Since our function for roses of red is 0.75x plus 20, with 20 being our y-intercept. The flower power y-intercept is 60. Of course, it crosses the y-axis, and we know from the y-intercept of 60, it would cross the y-axis at a place higher on the y-axis than roses of red. We'll later discuss our solutions in the form of the solution of inequalities, talking about every point in the regions that will be generated when we get our graphing calculator to generate inequalities from these lines. And we talk about all the solutions that are available, but for right now, we want to continue to examine the lines that our functions in our system generated. The 0.50 or the 50 cents per x in the flower power function represents the slope of that particular line. 0.5 translates into 1/2 as a fraction, meaning that that line goes up 1 and out 2. The change in y for our flower power line is 1, and the change in x in our flower power line is 2. The slope of that line is 1/2, which equals 0.50, the coefficient on the x in our flower power function. The coefficient on the x in our roses of red function is 0.75, meaning that the change in y is 3 and the change in x is 4, since 0.75 translates into 3/4, the fraction of 3/4, giving us a slope of 3/4 for that line. Overall, we've talked about the y-intercept of both functions and the slope of both functions, and we can very easily see that there is a solution to these systems that again appears to be in the center of our picture. Now we want to talk a little bit about the point of intersection. So let's go back to our graphing calculator and see if we can get it to let us know where our break-even point for both flower power and roses of red occur in our system. To get our graphing calculator to show us where our break-even point is that appears to be in the middle of our screen, we'll simply use what's called the intersect menu of the graphing calculator in our calculate section. So if we'll go second and use calculate over the trace button, you'll notice that in this menu there's an intersect mode. To get the calculator to go into intersect mode, we simply hit 5. When we do that, the calculator says, is my cursor on the first curve? To get to that for the graphing calculator, if you'll move your cursor away from the point of intersection, have your cursor on one or the other curve, and hit the word enter, the calculator will accept that as having been your first curve. Now it says, is my cursor on the second curve? And if you'll hit enter, if your cursor appears to be on the curve that was different from the first one that's marked, now the calculator says, give me a guess. If you'll hit enter again, the calculator will then calculate for you the point of intersection. If you'll hit enter again, both companies will have the same price after the homecoming committee purchases 160 stems of flowers, meaning that from the flower power company, if the homecoming committee purchases 160 flowers, they will pay the exact same price, which will be $140, as if they purchase 160 flowers from the Roses of Red company. They'll pay the same price, $150. Again, this area, this point of intersection, the solution to our system is called the break-even point. The X and Y values at our break-even point or point of intersection or solution of our systems represent the x being the number of stems of flowers, and the y equals the cost of the stems plus the fixed down payment. After having gotten comfortable with the graphing calculator to solve our system, now we'll talk about ways to do it manually, just in case your batteries in your calculator go out. First, let's start with the method of substitution to solve our system. Substitution will allow you to create a one-variable equation. A one-variable equation resulting from the two equations in the system. Now, to do that, first, we'll take the two equations and set them equal to each other, resulting in 0.50x plus 60 equaling 0.75x plus 20. From there, we'll solve the equations, subtracting 20 from both sides of the equation, resulting in 40 on the left side, and then subtracting 0.5x from both sides of the equations will give us the 0.25x. Then we'll divide both sides of the equation by 0.25, resulting in x equaling 160. That's the 160 flowers that we saw in the graphing calculator when we found our break-even point. To check that, we'll take the 160, put it back into the first equation of the system, y is equal to 0.50x plus 60, substituting in the 160 for the x, giving us y is equal to 140. The break-even point being represented from a method called substitution, x equaling 160, y equaling 140. Now let's take a look at the process of elimination. Elimination is when you add or subtract the equations to eliminate a variable. We'll need to change these equations to be able to fit the elimination process. To do that, we take the first equation and move the 0.5x to the other side of the equal sign, resulting in negative 0.5x plus y is equal to 60. When we move the 0.75x to the other side of the equal sign to change the form of this equation, just as we did the first equation, we result in a negative 0.75x plus y is equal to 20. To have our variables, or to have variables that will eliminate each other, we'll multiply the negative 0.75x plus y is equal to 20 by a negative 1, so that the y variables will then be exact opposites to eliminate each other, hence the process of elimination. Now we have 0.5x plus y is equal to 60. After the process of multiplying the second equation by negative 1, we get 0.75x minus y is equal to 20. Now the process of elimination takes place, resulting when we add those equations together in 0.25x plus 0 is equal to 40. Of course, we don't need to have a 0 represented there because 0 is nothing, and 0.25x equals 40, giving us a solution for x as x equals 160. Now, if we take the 160, substitute it back into the equation negative 0.5x plus y is equal to 60, replacing the x with 160, solve that equation for y, we'll end up with negative 80 plus y is equal to 60. Of course, we have to combine the opposite of negative 80 to both sides of the equal sign, resulting in y equaling 140. Again, our break-even point of x is 160, y is 140, has been found using another process, the process of elimination. On the screen, you see a representation of the graph for roses are red and flower power. We've got the function for roses are red being less than the function for flower power in this picture. This represents the fact that in this picture, from 0 flowers to 160 flowers, roses are red will clearly be the better choice. The Y values for roses are red in this part of the graph are lots lower than the Y values in flower power. If you'll notice, the red line represents the Y-axis, and the Y's for roses are red are a lot lower than the Y's for flower power, meaning that they're paying less for the number of flowers bought up to the breaking point from roses are red than they are for the same number of flowers being bought from flower power. Now, since we know which company the homecoming committee should shop with to be able to buy the cheapest flowers up to 160 flowers, let's take a look at what happens if they want to purchase more than 160 flowers. Reflecting back, the green line represents roses are red, and our purple line is representing flower power. Up to the purchase of 160 flowers, roses are red is the most economical company to shop with. But after, if the homecoming committee needs to purchase more than 160 flowers, look at what happens. The flower power company is the most economical company to shop with because the Y values along the flower power line are lower now than the Y values in the roses are red line, indicating that after purchasing more than 160 flowers, the flower power company becomes the most economical company to shop with. To summarize, from 0 to 160 flowers, roses are red should be the company of choice. From 160 flowers and more, flower power should be the company of choice. Now, since we just finished using the process of substitution and elimination to solve systems, we want to move on into the area of linear inequalities. We mentioned briefly inequalities earlier, stating that inequalities are the solutions found in the regions generated by the linear inequalities. Let's take a look at our graphing calculator and get our graphing calculator to generate some inequalities for us to examine. Now, to get the graphing calculator to generate our linear inequality to examine, we'll use the roses are red function first. Since our school will not allow us to spend any more than $100, we'll put in our $100 in our graphing calculator. For those of you who are using the TI-83, we'll need to graph $100 as a less than inequality because our school says we can spend $100 and less amounts of money. So we'll arrow over to the extreme left-hand margin, hit enter. If you'll notice the changes that are occurring, now we have less than highlighted. And this part will graph $100 and less than. Now we want to enter the function that represents roses are red, 0.75x plus 20. To have our graphing calculator generate this function, your window will more than likely have to be adjusted. Okay, the window I'm suggesting is the x min 0, the x max 352.5 with an x scale of 1, y min 0, y max 310, y scale of 1. To be able to generate this window, after you put your equations in, the y equals, if you'll use a zoom 4 to create a friendly window. Then go into your window, change your x min simply to 0, eliminating everything else out of that. Multiply your x max by 75. Change your y min to 0. Multiply your y max by 100. Now the reason I'm suggesting we start from a friendly window is to be able to trace to 100. A friendly window gives us friendlier numbers when we use the trace menu. To be able to find out how many flowers we can purchase at $100, we can simply trace, but better still, we can have the graphing calculator to find the point of intersection between those lines. And there we find that given a budget of $100, we can purchase 106 2/3 flowers, not to exceed the budget set by the school. We'll buy 106 flowers. Another way to have the graphing calculator tell you how many flowers you can purchase on a budget of $100 is to use the table instead of finding it on the graph itself. So let's take a look at the table in the graphing calculator and see what we can find. After having entered your equations, if you'll simply go second graph, if you'll notice above graph is the word table, you'll visit the tables that are made by the graphs, by the functions you've entered. If you'll notice that between 106 and 107 flowers represented by the X, we have 100 in our Y1 and 100 is between 106 and 107 in the X on the Y2, meaning that somewhere between 106 and 107 flowers can be purchased for $100. Again, causing us not to want to exceed the 106 number of stems to be purchased from Flower Power. Now, if we go back into our y equals, change the function to our roses are red function, which is 0.50 x plus 60, we'll do the same type of examinations. Leaving our window as is, if you'll graph, you'll see the y equals 100. We want money less than 100 to be spent. We want to find out where this point of intersection is. Therefore, instead of trying to trace to it, we'll simply use our intersect menu, second calculate, 5. If you'll hit enter to indicate your first curve, enter for your second curve, use your left arrow or your right to get the cursor near the point of intersection, hit enter a third time, you'll find that from roses are red, we can purchase only 80 flowers within the budget set by the school. To summarize what we just did with our system of inequalities, we'll take a look at our solutions we found for Flower Power and for Roses Are Red within the budget of $100 set by the school for the homecoming committee. 80 stems can be purchased from Flower Power on the school's budget, and 106 stems can be purchased from Roses Are Red on the school's proposed budget. Those are called solutions of a system of linear inequalities. A solution of a system of linear inequalities are the numbers that make the inequality in the system true. Now, let's review all we've done and sharpen your skills even more. We've worked with systems of linear inequalities. We've talked about the different types of solutions systems of inequalities generate, such as the solution of a system being the common point or point